Hey guys, this is just a quick update on my C programming language. I'm starting to actually make the actual language. That sentence kind of was horrible, but we're just gonna keep going with it. Um, in previous attempts at making the language, I've always done like all the expressions first, and then I try and add variables, and then I add functions and stuff, and then the variables or functions ends up being too hard. So I've only added very basic expressions, just enough that I can then get variables working because I want to tackle the harder things first so that I don't waste time. So what I'm working on right now is I've sort of got variable declarations mostly working, but I'm not sure how I can get them working to later allow for the operators that I want to add. In a lot of languages like C# and Kotlin and stuff, you have a lot of null safety operators. And I really want to implement these. So there's like the null safe access operator, and then there's the null coalescing operator. The null safe access is sort of like, suppose you have some structure and you're trying to access a property of it. If X is possibly null, meaning it's a nullable type, which is denoted like this, like a normal int would just be this part, but an int that could possibly be null has a question mark. And so if you tried to do this where X is nullable, it wouldn't allow you to. It would say X is possibly null, so you can't access it because you could then possibly access a null value. So what you as a programmer would have to do is either assert that it isn't null, like this, which in Kotlin, if X is actually null, it would throw like a null pointer exception, I think. But in my language, since it's based on C and we don't have runtime exceptions, all it would do is errors might happen if you use this, but at least you have to acknowledge that that's the case, so it's better than not having it. Or you could do something like this where you do a safe access. And what this expression is, it essentially says, if I just write in pseudocode, if X is null, just return null, otherwise return X dot Y. So the value of this expression is either null or X dot Y. So it won't actually do the access if X is null. And then there's the null coalescing operator, which it looks a lot like the ternary operator in C because it essentially is. Except it's only one-sided. So all this expression says is if X is null, if X is not null, this evaluates to X. Otherwise, it evaluates to Y. It's kind of like saying, it's essentially the exact same as this in C. If X is not falsy, which would mean not null, hopefully. Sometimes it could also just check if it's 0 or false. But you could say if X is not null, return X, otherwise return Y. But it's all just compacted for the sake of the notation. Why repeat X twice? And so the issue is with nullable types in my language, that requires me to use pointers. I don't have like a pointer syntax currently in C because I want to abstract away that concept. I don't want you to manually be passing around pointers and things if I can help it. But since I'm transpiling into C, I have to actually use them underneath. So if you made a declaration like this, or even better yet, let's just start with a normal int declaration. It would be something like this. It would just be, you make a variable x, that's an int, you make an int x. But if you make a nullable int, what that means is it might be null. So what we have to do is we have to declare an int to hold the value, and then we declare x itself, which is a pointer to that value. Currently the value holds nothing, but suppose I said this is equal to 5, then it would set this value equal to 5, and then we could access it through the pointer, which eventually could be assigned to null. So if we look at assignment 1 and we have x is null, coalesce operator 10. Now this will always evaluate to 10, but I can't know that at compile time. Like hypothetically, I could do some sort of static analysis to know that this is only a null, but hypothetically this could be some other variable like a y that's declared higher, and this might be null, it's just some nullable type. In this case, I'm just using null as an example. the assignment would have to look something like this. The good thing about this sort of expression, and note that you can chain them, you could have a bunch of these chained together, which is going to be a very big pain. In this case, 10 is not a nullable expression, so we can just directly assign it to the x val. Then for the value of x, what we can do is we can check, is this thing on the left null? Like this. And if it isn't, we just assign x to it. Otherwise, we assign x to 10, which has to be pointer syntax, because null is essentially pointer syntax. And you have to just say x is the memory address of the thing that contains 10, which is a big hassle. And suppose now we make a variable y, which is also nullable, and we set it equal to x if x is not null, otherwise we set it to null. And now notice that both sides of these are nullable, and that's a big pain. So before we could just set the right side into the value, but now we have to do a check. We have to check, is x itself null? And if it isn't, we can dereference it. Otherwise, then we have to assign the right-hand side and check, is this thing null? And if it isn't, we dereference it, or we set it to just some junk value. Notice that I can't know if the thing on the right side is null. I don't think. Like, I might be able to do a static analysis to know. I could add some data or stuff, but suppose this thing again were a different variable. Maybe if that works. Like, suppose I change, let me see. Because the issue is, currently, if I run this, you'll notice that there's a problem. And the problem is that I'm trying to dereference null. And even though I only dereference null when this is true, and this is never true, it's still, C still complains. So let me see, if I replace this with X. Okay. But that's weird, kind of, because before I had like a variable null that specifically was a variable so that I could attempt this. But the issue again is just the difference between values and pointers. Because like, okay, this like mostly works, right? And then what we do is that gives a value into y val. And then to set the actual y pointer, we have to check again, is x null? And if it isn't, we set it to y value, the address of y value, because that will, the same condition, contain the value of x. And we have to do that because we don't want x and y to refer to the exact same integer memory, because that means that they're going to modify each other. We just want to set it to the value that's at there. And then if x is null, we set the pointer to null. And there's a lot of other issues with this sort of syntax, other than the ones I've pointed out so far. One of the big ones is just temporary values. If you end up typing something like, suppose we use the other notation, or yeah, suppose we call a function and we try and evaluate like a nullable func. Did it return null? And if it did, we just do something else like this. The way that this would sort of transpile is you would call func here, and then you'd have to call it again. But you notice, of course, that's a huge problem. Because you can't just like, if you call it again, the value might change the second time you call it. So this sort of, you'd have to like make a temporary value to hold the value of func. But the big issue that I'm like struggling with is the value of func has to return a pointer, I guess, right? But is that going to be a stack pointer? Is that going to be a heap pointer? Is that going to just be a null pointer? Like, I can't know until runtime, and it's just kind of unmanageable. So I don't know if I can save these two operators. I can keep the concept of nullable, hypothetically, so that you have a nullable type. No other types can be set to null. And then maybe I could still have a null assignment. It's going to be hard to even like an expression like this is hard to figure out, because you have to figure out, okay, the thing on the right is null. So we have to set the pointer to null, not the value. What I might end up doing is do something like this to reference the pointer, where it's sort of like you're assigning the pointer the value of null, but then you can't have things that are conditionally null. You know, it has to be, you couldn't set x equal to something like y here. I mean, I guess you could, but then that would get rid of Rust's memory management stuff. So I really just don't know what to do with this right now. I guess I can look more into how Rust does a concept of null, and I don't know, I've just been thinking about this for the last few hours. It was hard to fall asleep last night because I was figuring out that this was going to be a problem. I could ditch the concept of null safety, but even then, if I have a value of null, it's going to be so hard to assign it to anything just because of how C works. It's not Java. I want it to work kind of like Java does, but it just isn't Java because I have to deal with pointers. And it's hard to assign a value to a pointer or to the pointer's value conditionally and know what you're supposed to do at runtime, at compile time. So, I don't know. If you guys have any ideas, let me know. Otherwise, I don't know. I'm just going to have to... I'm either going to have to drop the concept of all this null safety stuff. I might keep something like this where you just can't use null at all unless it's a nullable type, and then you have to do like a manual if statement sort of check manually, and then you'll just have to assert that it isn't null. And that's just some kind of safety. I think that might be better than having nothing. It might be. But I'm not even sure I can make that work just because of the things I mentioned before about like assigning null to a variable. Unless I can create an abstraction that just works better for this sort of thing. Or maybe I might have to make a pointer syntax. And I'm not going to do like pointers to pointers to pointers and things. I really don't want to do that because that caused me a ton of issues last time. I want to simplify down C's types, but I also don't know if that's going to remove functionality or not. But anyway, I think that's going to be it for this quick little video because I could keep talking about the same thing going in circles for a long time, so I'll just have to spend time and think about this. But yeah, I guess I'll let you guys know what I end up doing. And yeah, I'll see you in the next devlog.